extent you have understood?
Yes, sir.
Okay, very good. Now suppose you want to find the length of segment APB. Okay, so how you will be finding? Suppose you are able to find out the length of AB.
Yes, sir.
Correct?
Yes, sir.
Then you will be able to find out length of this one.
Yes, sir.
2 pi r minus.
Yes, sir.
Okay. You know that circumference of a circle is 2 pi r.
Yes, sir. 2 pi r minus theta.
Right. So now you can say that arc length. Suppose this length is L.
Okay, sir.
Okay. Suppose arc length, arc AB, and it is length of arc AB is equal to L.
Yes, sir.
Right. Okay. Very good. So now this L is equal to what? L is equal to arc theta. L is equal to
Arc theta.
arc theta. Right. Now, so AB length is arc theta.
Yes, sir.
So this is the length of, you can say, minor segment
Yes, sir.
or minor arc.
Yes, sir.
Then major segment. We know that total length of this circle is called 2 pi r, circumference of
Yes,
this
sir.
circle. So 2 pi r minus arc theta.
Yes, sir.
Yes or no?
Yes, sir.
R into 2 pi minus theta
Okay, sir.
will be the length of the remaining segment.
Major segment.
Remaining segment,
Yes.
major segment. Correct? Okay. So with this, you will be able to find out length. That was area of the sector. Area. And it was area of this sector AOB. Then if you are, you can say, subtracting from pi r square, you are getting area of this sector.
Okay.
Yes or no?
Yes, sir.
Okay, very good. So let us discuss about tangent now in detail. So tangent. Suppose at any point P and this is T. Okay? At any point P and this is the center O.
Okay, sir.
You are joining the point of contact here. This is called point of contact. P is called point of contact. Okay. Point of contact of this tangent on the circle. This is P. Okay. Now this OP is always perpendicular to the tangent. Is always perpendicular to the tangent. OP is always perpendicular. Perpendicular means what?
Which divides the line segment into two parts.
No, man. Which is making 90-degree angle, that's all. Which is making 90-degree angle. Perpendicular means 90-degree angle. No dividing the line into two parts and all. Suppose this line is there, I am drawing a perpendicular here. Whether this, it is dividing this line into two parts. Not dividing the line into two parts. Okay, so it is only making 90-degree angle, correct?
Okay.
So perpendicular means making 90-degree angle. So how it is proved? It is proved by a statement. So what it is, suppose you are joining this line OT. Okay. Now what it is there? You are finding out that OT is greater than OP.
Yes, sir.
Yes or no?
Yes, sir.
OT distance is greater than OP.
Yes, sir.
So once you are reducing this distance from T to P, if you are coming back, you will be coming back to P. Okay. So this OP will be the shortest distance.
Okay.
Shortest distance
Okay.
between O and P. This only will be the shortest distance.
Yes, sir.
Then this one.
Yes, sir.
Okay. So as OP is the shortest distance for the point P from O, and we are knowing that shortest distance always used to be perpendicular. Shortest distance It is always perpendicular. Suppose two lines are there. Now if you really want to find the distance between two lines, then you need to draw a perpendicular from one line to another line, so that this will be perpendicular to both the lines.
Yes, sir.
And that perpendicular will be giving you shortest distance between the lines. Shortest distance between the lines. Okay?
Yes, sir.
So which is perpendicular will always give you shortest distance. Therefore, OP is perpendicular to PT. So by statement only it is proved. So what it is proved? So it is one theorem. It is theorem. The line joining from the center to the point of contact of tangent will be or is perpendicular to the tangent, is perpendicular to the tangent. Okay. Now we will discuss some of the questions from exercise 10.1. Yes or no?
Yes, sir.
Okay. So we will have a discussion from exercise 10.1. So what is the question says? How many tangents can a circle have?
Yes, sir.
How many tangents can a circle have?
Within 1,
And
2, 3, 4.
So we cannot count.
Yes, sir.
For each and every point,
Yes, sir.
tangents will be there. So you can say that infinite. Okay? How many tangents?
Infinite.
Infinite number of tangents. Number of tangents a circle can have. Okay, question number 2. What it says? It says that fill in the blanks.
Yes, sir.
Okay, what is the first question?
A tangent of a circle intersects it in dash point.
How many points a tangent is intersecting a circle?
Infinite.
How many?
1.
How many points? Okay, this tangent is intersecting at the circle. Only 1 point. Only 1 point. Okay. Then second one, a line.
Intersecting a circle in a 2 point is called.
A line intersecting a circle in 2 points is called. See, line. What I told you that when the line segment is only touching the circumference of the circle and it is not being extended like this,
Yes, sir.
then it is called a chord.
Yes, sir.
But when line is crossing the circle like this, then it will be called as secant.
Secant.
What it will be called as? Secant.
Secant.
But this is only line segment,
Yes, sir.
which is called chord. Right?
Yes, sir.
So in this case, what you will be writing? A line intersecting a circle in 2 points.
Yes, sir.
Line intersecting a circle in 2 points is called
Secant.
secant. Is called secant. Very good. Third question, what it says, gentlemen?
A circle can have dash parallel tangent at the most.
A circle can have parallel. So you can say that this is a circle. Suppose this point you are taking one tangent, correct?
Yes, sir.
Right. Now parallel to this tangent, somewhere here one tangent will be there. Okay. Now this tangent will be having one point here. So we can draw parallel tangent only 2 at a time.
Yes, sir.
For this one will be parallel. For anyone else, like this it is there, this one will be parallel. For this, you can say this is parallel, so like this it will be parallel.
Yes, sir.
Or something it is there, so at a time parallel tangents can be drawn only two.
Okay, sir.
Only two parallel tangents can be drawn to a circle.
Okay.
Infinite number of tangents can be drawn,
Yes.
but parallel tangents can be drawn only two. Because this is not parallel to this one. This is parallel to this one only.
Yes, sir.
Yes or no?
Yes, sir.
Huh?
Yes.
Parallel lines you know.
Yes,
So
sir.
a circle can have
Two parallel.
parallel tangents. At the most, maximum two parallel tangents. Right?
Yes, sir.
So two parallel tangents. Okay, fourth one, what it says, the common point of a tangent to a circle and the circle. So common point, this is the point. What I told you, this point,
Common
what it is?
point of contact.
Point of
Contact.
contact. So this point P is called point of
Contact.
contact. So point of contact. Understood? It is called point of
Contact.
contact. Very good. Now, note it down.
Yes, sir.
Very good. Can I have this side?
Yes, sir.
Theorem noted down. This theorem. Okay. What is question number 3?
A tangent PQ at the point of P. of
At a point P,
Yes, sir.
suppose this is the circle.
Yes, sir.
Okay. So a tangent PQ.
PQ.
Right. So this
At
is
the-
PQ.
Yes, sir.
At
At the
the
point of
P of a circle. Right.
Radius 5 centimeter.
Radius 5 centimeter. Suppose O is there and this is 5 centimeter radius.
Meet lines.
Meets a line through the center O at a point Q. Correct?
Yes, sir.
Okay, so this is there and this is Q. So this is meeting in this way.
Yes, sir.
Right.
So
That
OQ is equal to 12 centimeter.
very good. So OQ is equal to 12 centimeter. Right.
Length PQ is.
Length PQ is. So this length X we need to find out. Yes or no?
Yes, sir.
So what? What I told you, OP is perpendicular.
Yes, sir.
OP is perpendicular to the point of contact.
Yes, sir.
Once it is perpendicular, it is becoming a right angled triangle.
Yes, sir.
Okay. So just see here first. In triangle OPQ. So right angle at P. Yes or no?
Yes, sir.
Why? Because OP is perpendicular to PQ, being a tangent. Being PQ is a tangent. Right?
Yes, sir.
Okay. So Pythagoras theorem we can apply?
Yes, sir.
We can apply Pythagoras theorem?
Yes, sir.
So if you are applying Pythagoras theorem, so here you are getting OP square plus PQ square is equal to OQ square.
Yes, sir.
Right. OP is given to you 5 centimeters.
Yes, sir.
Okay, 5 square plus PQ. We are not knowing X we are writing.
Yes, sir.
What we are writing?
X.
X. So X square. OQ is there?
Yes, sir. 12 centimeter.
Very good. So X square is equal to 12 square minus 5 square. 144 minus
25.
25. So X square is equal to what? So 14, 5, 9, 3, 2, 1, 1. Yes or no?
Yes, sir.
So X is equal to plus minus whole root 119.
Yes, sir.
What? Centimeter.
That's all, sir.
So minus is possible?
No, sir.
Length is not possible in minus. Okay. Therefore, your PQ is equal to whole root 119 centimeter. Whether 119 is you can say perfect square.
No, sir.
It is not a perfect square, so we can write P2 is equal to whole root 119 centimeter.
Okay, sir.
Yes or no? Okay, so answer will be D.
Okay, sir.
D answer is there?
Yes, sir.
Yes, so answer will be D. Okay.
So what is that one, sir? From the line joining from
The line joining from the center to the point of contact, of tangent is perpendicular to the tangent.
yes, sir.
Okay, therefore angle OPQ is equal to 90 degree. Is equal to
90 degree.
90 degree. Very good. Note it down.